Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about concept of probability density function. The derivative of cumulative distribution function with respect to some dummy variable is called as probability density function. CDF stands for cumulative distribution function, PDF stands for probability density function. The probability density function of a discrete random variable is often known as probability mass function. The probability density function is also called as frequency function. Mathematically, the probability density function is given by or defined as fx of x is equal derivative of distribution function. And cumulative distribution function is represented by capital F of x or capital Fx of x. And probability density function is denoted by small fx of x or simply f of x. The derivative of the distribution function is equal to probability density function. This is the mathematical definition of the probability density function. Thus, the probability density function of a discrete random variable is an impulse function. So, this is the definition of the probability density function. The probability density function is the derivative of the distribution function. Capital Fx of x is the probability distribution function. Small fx of x is the probability density function. But we know that the probability density function for a probability distribution function for a discrete random variable is sigma probability of xi into u of x minus xi. So this is already discussed in previous classes, and substitute probability distribution function value here. We get the probability density function fx of x is equal, applying the derivative into unit step function. So that is sigma I p of xi into d by dx into u of x minus xi. U of x is the unit step function. U of x minus xi is the unit step function at x is equal to xi. And the derivative of the unit step function is the unit impulse function. Similarly, d by dx of u of x minus xi is the shifted unit impulse function. That is del of x minus xi. So therefore, for a discrete random variable, the probability density function is fx of x is equal sigma I p of xi into del of x minus xi. Sometimes the probability density function simply called as probability function. For example, for a discrete random variable having a staircase form of probability distribution function, unit impulse function del of x is used to describe the derivative of the probability distribution function at its staircase step point. So this is the probability distribution function is already discussed in my previous video. In that video, for a discrete random variable having a staircase form of probability distribution function. So unit impulse function del of x is an unit impulse function. So unit impulse function is used to describe the derivative of the distribution function at its staircase step points. This is because the derivative of the step function is an unit impulse function, and it is given by mathematically the unit impulse function del of x is equal the unit impulse function del of x is equal d by dx into d by dx into u of x, where u of x is an unit step function, del of x is an unit impulse function. The derivative of the unit step function is an unit impulse function. For example, let us take the experiment of rolling a pair of two dice So rolling a pair of 2 dice, totally there are 36 possible outcomes. Since each die may show any number from 1 to 6. So rolling a single die, the die may show any number, that number from 1 through 6. So rolling a pair of 2 dice, the total outcome of the experiment are 36. So therefore, the sample space is given by or written as S is equal 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4 and so on 6 comma 4, 6 comma 5, 6 comma 6. So these are the possible outcome of the rolling a pair of 2 dice. So totally 36 possible outcomes. Okay, the impulse function is the derivative of the unit step function, that is del of x is equal to derivative of the u of x. The impulse function symbolically is drawn as a vertical arrow. The impulse function graphically, the impulse function is represented by or drawn by vertical arrow whose height, impulse function height, is equal to the amplitude of the step function for which it is the derivative. So now here in this example, rolling a pair of 2 dice, totally there are 36 possible outcomes. So each outcome may be represented by generally lambda suffix ij, where I is the suffix I represents the number shown on the first die and suffix j is the number shown on the second die. Let small n represents the sum of the numbers appearing on the dice. That is, I plus j is equal to n. I is the number showing on the first die and j is the number showing on the second die. N is the sum of the numbers appearing on the dice. So the sum of the numbers appearing on the dice n is equal I plus j. So in the above sample space, totally there are 36 possible outcomes. So in that combination, um, the sum of the numbers appearing on the sum of the numbers appearing on the dice, that values of the n are small n is equal 2 to 2, 3, 4 and so on 12. So 1 comma 1, 1 plus 1, I comma j. And suffix I represents the number showing on the first die and suffix j represents the number showing on the second die. So now here what is the first outcome? 1 comma 1. So 1 plus 1 2. And what is the starting value of the sum of the numbers appearing on the dice? 2. 6 plus 6. 6 plus 6 12. And the maximum value of the sum of the numbers appearing on the dice are 12. So the value of the n is varies from 2 to 12 for all values of n. So that are n is equal to 0 to 12, we can determine probability values. So but we know that the basic definition of the probability is number of favorable outcomes by total number of possible outcomes. For all values of n, we can determine probability values. That is probability of 0, probability of 1, probability of 2 and so on up to probability of 12, we can determine probability values. First calculate probability of 0, probability of the 0. In the above sample space, some of the numbers appearing on the dice. Zero sum appearing on the dice, there is no possible combination. So therefore, the number of favorable outcomes are 0. Total outcome of the experiment are 36. Therefore, probability of 0 is equal to 0 by 36 is 0. Next, find out probability of 1. In the above sample space experiment, there is no possible combination of sum of number 1 appearing on the dice. So, the number of favorable outcomes are 0 by total outcomes are 36. 0 by 36 is 0. Next, find out probability of 2. In the above experiment, in the above sample space, in this experiment, this is the sample space, sum 2 appearing on the dice. The sum 2 appearing on the dice 1 plus 1, one possible combination of the, and this is the one possible combination of the sum 2 appearing on the dice. So the favorable outcome is 1. The favorable outcome is 1. And the total outcomes are 36. So therefore, probability of 2 is equal 1 by 36. Next, find out the probability of the 3. Sum 3 appearing on the dice. Sum 3 appearing on the dice. Here the favorable outcomes are sum 3, 2 comma 1. This is one combination. 1 comma 2. This is the second combination. So the sum 3 appearing on the dice. The possible combinations are 2 by total outcomes are 36. 2 divided by 36. Probability of 3 is equal to 2 by 36. So similarly, we can determine probability of 4, probability of 5, probability of 6, probability of 7, probability of 8, probability of 9, probability of 10, probability of 11, probability of 12 values. So the same concept is already explained. This calculation of the same calculation already explained in previous topic, that is probability distribution function or the cumulative distribution function concept. So please refer that topic. And after that, draw the graphical representation of the probability density function versus values of the n. So now here, what are the values of the n? The values of the n are n is equal to 0 to 12. X-axis is values of the n, that is 0, 1, 2, 3 and so on 12. And y-axis is probability density function. Sometimes the probability density function is called as a probability function. Now here, what are the values of the probability function? The minimum value of the probability function value is 0 and the maximum value of the probability density function is 6 by 36. So that are in y-axis. For n is equal to 0, the probability value is 0. N is equal to 1, the probability value is 0. Next, n is equal to 2, the probability value is 1 by 36. So now here, probability density function. The probability density function is the derivative of the distribution function, and the derivative of the unit step function is the unit impulse function. Symbolically, the unit impulse function is drawn by vertical arrow. So for n is equal to 2, the probability value is 1 by 36, that is drawn by vertical arrow. Next, n is equal to 3, the probability value is probability density function or probability function value is 2 by 36, that is drawn by vertical arrow. So that is the impulse function. Impulse function is the derivative of the step function according to the definition of the probability density function. So what is the graphical representation of the probability distribution function? That is a staircase form, steps, unit steps. So differentiating the steps, we get impulse function. So the impulse functions are drawn by graphically vertical arrow. Next, value of n is 4. At n is equal, for n is equal to 4, the probability value or probability density function value is 3 by 36. 3 by 36. Next, n is equal to 5, the probability density function or probability function value is 4 by 36. N is equal to 6, the value is 5 by 36, that is drawn by vertical arrow. And n is equal to 7, the probability function value is 6 by 36, that is drawn by vertical arrow. Next, n is equal to 8, the probability value is 5 by 36, that is drawn by vertical arrow. N is equal to 9, the probability value is 4 by 36, that is drawn by vertical arrow. Next, n is equal to 10, the probability density function or probability function value is 3 by 36, that is drawn by vertical arrow. N is equal to 11 and its value is 2 by 36. n is equal to 12 and its value is 1 by 36. So this is the graphical representation of probability function or the probability density function versus values of the n, and small n is the sum of the numbers appearing on the dice. Now we are considering the experiment or example is rolling a pair of 2 dice. This is the concept of probability density function with example.